So as I said, at this point in the notes, you can actually do all the exercises that are listed. I'll just have to add 2 exercises because I forgot to cover them in the exercises list. So we are going back to the first page just below the fundamental theorem of calculus. There's one more thing you have to know. This really is the same as the fundamental theorem of calculus. It says that the derivative of the integral of a function is the function itself. Note how you cannot have the same variable here, it's f of t dt, as you have up there. This variable here will be the variable you use when you differentiate. Let's see how we get to this equality. The left-hand side is d dx integral from a to x of f of t dt, a being a constant number. Any constant is fine. By using the second part of the fundamental theorem of calculus, I find that this integral here is actually capital F of the upper limit minus capital F of the lower limit. And when I take the derivative of that, the derivative of capital F is f of x minus the derivative of a constant, which is 0. So I'm simply left with f of x, and that's indeed what I have on the right-hand side of the inequality here. Let's see what this looks like on a few examples. Example 1 is very easy. Example 2 and 3 are much more difficult. So d dx integral from 7 to x of cosine t dt. This I can immediately apply this rule there. 7 is a constant, so that's fine. X is up here, that's perfect. So the result is cosine of x. In example 2, it's different because even though I have a constant here at the bottom, which is great, I have x squared up here. And x squared is not okay, I really need x. So what I have to do is to make a change of variable, and of course I'm going to set up u equals x squared. So the first effect is that I have u up here now. The second effect is that I want d du here. I can't have d dx anymore because I need a d du to match with this u up there. So I can change d dx as being d du times du dx. And what is du dx? It's 2x, simply because u is x squared. So if I keep the d du here, and I change du dx as being 2x, here is a new expression, and this time with this part here I can use the expression at the top, that, and say that this is sine of u. The 2x stays, so I get 2x times sine of u. And finally I need to change u back to x, because x is the variable we want, so the answer is 2x times sine of x squared. Example 3 is even a little bit harder, because this time not only do we have x squared as an upper limit, we also have 2x as the lower limit, and we have to have a constant in order for this rule to work. So the first thing we do is we use the properties of integrals, and we break this down into 2 integrals. I can say that this is the integral from 0 to x squared minus the integral from 0 to 2x. So this is the only thing I did on this first line. I rewrote exactly the same, except it's from 0 to x squared minus from 0 to 2x. And I need to treat these 2 integrals separately. I'm going to repeat exactly what I did in example 2 for the first part. I'm having u equals x squared to have a u here. Du dx is 2x, which I can change, and now this 2x times du integral from 0 to u is simply 1 over 2 plus e to the power of u. For the second integral, what I need to do is change this 2x, so I'll have a change of variable v equals 2x. Therefore, dv dx equals 2. And if I make the change that d dx is actually d dv times dv dx, this is what I get. Now everything works. I have a constant at the bottom, I have a variable at the top. This variable matches the d dv, so it matches the derivative. I can use the rule and say that this is 2 times 1 over 2 plus e to the power of v. And finally, in the last line, what did I do? I just reset all the variables I used to x. So e to the power of u is actually e to the power of x squared, and e to the power of v is actually e to the power of 2x. This example 3 is a little bit beyond what we're going to see in the exercises, but here are the 2 exercises I'm adding to the list. You will need to do them. These kind of questions like example 1, 2, 3 really do come in AP exams, so the textbook doesn't focus on them as much as AP does. But here are 2 examples of simple exercises you can do using this rule. Exercise 93 and 101. Thank you very much and see you next week.